Hello everyone, this is Tim here again with One Handy Guy. I just wanted to do something that I wish somebody had done for me when I started working with Langmuire Systems, their Crossfire XR, and also working with Fusion360. They've got some tutorials there on the website, but if you're new to this, it can be very, very confusing. Let's go to their website and I'll just show you what I'm talking about. If you go to their home page right here and just click on support, and you can scroll down here and hit CAD CAM with Fusion360, and that's primarily what we're going to be working on. I want to do like a series of videos here to discuss how Fusion360 works with their fire control system. So these two in particular is what we're going to focus on in the next few videos, just to try and help you get started if you're not real familiar with either one of these systems. So if we click here on CAD CAM Fusion with 360, you go into a series of videos that are really good training videos to start out as far as how to install Fusion 360. They do have a free mode. It's a little hard to get to the free mode, but you can do up to 5 projects at a time without having to actually pay for it. The downside of that is you're constantly having to delete different drawings that you've done to start a new one, which is fine when you're starting out, but eventually you're going to have to go to the paid version. It gives you a good tutorial on starting a sketch, basic dimensions, all these different things, which are really good videos. I don't want to try and mirror or do whatever they're showing you to do there as far as Fusion 360. Where the issue I found comes in is when we get to this part, where we get to the CAM part, the computer assisted manufacturing. That's where it gets a little confusing, and we're going to do a lot of testing with this. Let you just see what changing up some of the settings does to different parts, and let you see how to fix issues that you may or may not be having. So in this particular video, we're just going to talk about it on the video, show different on-screen shots of actually manufacturing a part in Fusion 360. And then in the next video, we'll cut those parts out, and we'll continue to do this with different sizes, different thicknesses of metal, different parts, so you can see just exactly what each of those settings mean. So again, like I said, when I watched these videos to begin with, they were good videos, but I didn't understand half of what they were saying because I'd never done any plasma cutting before. So I'm going to try and explain that to you from a beginner standpoint, and hopefully it'll make a lot more sense to you. So with all that being said, let's jump into Fusion 360. We're just going to make something really, really simple, do some letters. Hopefully we don't have an update coming in, but we'll just have to play it by ear and see what we got. Sometimes when Fusion 360 takes forever to load, that means they're doing an update, but we'll find out here in a second. I can see it on my computer. Y'all can't see it, but down in the bottom right corner where the icon's bouncing up and down, so that means more than likely we got an update that's working its way in. She's trying to load. All right, there we go. All right, and unlike my other videos, I'm going to try and move this a little more into the screen where you'll be able to see it all. Hopefully that will help. Okay, so let's just start by designing a simple part, and I've decided probably the best way is just to go with some lettering. So, and I want to do about a 3-inch letter. So I'm just going to come up here to create and hit text, and we're just going to draw a simple box here. And I think we're going to stick with just the letter A. Let's take it to a bold, like Arial black, and we'll make that bold. And we're going to make this right now. You see the height's pretty small, so we're going to make this, let's make it 3 inches. So So that'll give us a good size to work with, but not burn up too much metal. So I'm going to throw it here to the center. And just kind of get it stabilized in my box, and we're good to go there. Okay, so we got a simple letter A that we're going to be cutting out, and we want to see how everything is affected. Now, first thing we got to do with that A, you'll see it's real fuzzy around the corners. So we want to right click with most computers. If you're using a MacBook like I am, you just push 2 fingers down, and we want to explode the text right here. So we're going to hit explode text, and notice it's going to create a line. Now, a couple things you need to remember about this. If I want to just keep the letter A, let's say I want just the letter A, I want to keep that and use that. All right, I'm not going to do anything, and you can see that's exactly what it's going to cut out like. But let's say I were going to put it in a sign of some sort. So let's just create a little box around it. All right, and now you can see when I click on this, if I cut it out, this is what I'm going to get, because this diamond here in the middle is going to just fall out, and I'm not going to have a very good pronounced A. So in this video, we're going to just focus on the letters, and then in the next video we'll focus on what settings you need to do if you want to do this. So just to give you a good example, if I needed this letter to stand out in my drawing, I need to connect this so that this is not going to fall out. And I'd simply do that by grabbing my box tool, come over here, and run about like that. Now I'm going to take my cutting tool. The other thing you'll notice, I'm going to get rid of my dimensions, my constraints, and my points, so I've got an uncluttered desktop. Alright, so now I'm going to come and hit trim, and I'm going to get rid of these parts of the box that I created. And what I did in essence, I just opened this up to where it becomes a part of the outside. So now if I click on this, you can see I get a much more distinguishable letter A. Alright, but for this video, and we'll come back to that in one of the future videos, but for this video we just want to see how letter A is going to cut out on a sheet of metal if we wanted to use those letters. So let's just undo everything we just did here. And we're going to go back to no box, and there's our letter A, and we're going to cut that out. Alright, so we've got this done. We're going to finish our sketch, and now we're going to save it. So we're going to just put this as A test 1. Alright, and we're going to save that. Alright, now we're going to move on to our manufacturing. This is where we're doing the actual cam part. This is the part of the video that wasn't real clear in Langmuire's setup. So let's click on manufacture, and there's just a few things we got to be able to do here. So the first thing, there's only 3 tabs you really got to pay attention to of all this up here. So the first thing is our setup tab. So we're going to click setup. Alright, and you'll notice we got a lot of options here. I want to keep this simple. So the first thing we're going to do is select our machine, and in my case I'm using the Razor Weld 45. Came with the machine. It was a good buy. It's been a good machine. No complaints. And notice it says Fire Control version 1.6 CPS. So that's the post-processing software that you can download from Langmuire's website that you'll actually put into Fusion360 as your post-processor. All right, and they've got a good video on how you do that. All right, so we're going to select the Razor Weld. We'll select that. All right, so we got our machine, our setup, we're cutting. These are my different options: milling, turning, cutting, additive, which we're not adding to, so we're just cutting. And with a plasma cutter, really that's all you're ever going to be doing is cutting. So don't make it more complicated than what it is. All right, work coordinate system. All right, your orientation. According to the website, they say leave it on model orientation. which if you read down here, let's go back. Whoop, I guess we're going to have to read it without the pointer. It says uses the orientation of the current part of the WCS orientation. So that's what we're going to leave it on, is just model orientation. I think all the rest have to do with if we're using all three axes, which, I mean, technically we're using the Z axis as torch height control, but we're not milling. So let's just leave it in model orientation. All right, the origin, we're just going to leave that at stock box point, which is what we're fixing to mark out, and then it says stock point. All we're saying is where do we want the cut to originate. So I'm going to point in that bottom left quadrant, and I'm going to say that's where I want to line up my plasma cutter to begin this cut, is down in that bottom left corner. And that just makes it easy for orienting your part on the machine. All right, then we got to pick what we're actually wanting to cut. So all we got to do is go up here to click sketch and click on that, and notice it's A test 1 version 1. That's what we're going to cut out. We don't need to worry about the stock. We don't need to worry about the post process. That's already been uploaded. Okay, so, and we're going to change that in this video. So let's just leave that as it is. Once again, just worrying about this setup. Get this one, and this one covered, and that's it. So we click OK. And you notice we got a green check, says, all right, we're good to go. The next tab we want to go to that we're really worried about, or actually only worried about, is the cutting. So we go to the cutting, and notice we get another tabbed window right here. All right, once again, we have to select which machine we're using. So we go to the library. If you've uploaded it, it'll be right there. We click our razor well 45, and notice it automatically sets defaults in here. This is for the cutting feed rate, and you're going to find this is critical in your cutting process to get this right as far as what speed. Now I know razor well doesn't really have a cut chart out there. You can Google it and you can find them. They're all over the place. I found them not to be very helpful because it seems like the company itself has not produced a cut chart, so it's all individuals out there. And you're going to learn that you have to just play with this number to get the right cut. So, and luckily we can do that in the fire control software, and I'm going to show you how to do that whenever we go to cut this out. So we're going to stick with, right now I've got my cutting feed rate set at 80 right now. Notice these 3 rings over here. So I could change it, I can add it. If I say, okay, let's reset the system default. That's 40. Well, I don't want that. So we're going to take it back to 80 because I'm going to be cutting on 11 gauge, which is roughly an 1/8 inch. And I'm going to put that back at 80 inches per minute. And we'll play with it when we get to the fire control software to see if we want something faster, slower, whatever we got to do. All right. So really that's all we're cutting through. We're not etching. We're not doing anything else. So we're just through cuttings. The only setting we got to fool with there. If we say through high quality, I've found that that does absolutely nothing. I've never tried it on the etch, and we'll try that after we get this first cut. We're going to try some of these other settings just to see what it does. But part of this is I'm learning with you. All right, I think we got we're going to leave all this alone for right now. We'll leave our cutting mode at cut through. We've got our machine picked. We've got our feed rate set. The preset is custom because we changed it. All right, next thing we want to go to is where it says geometry, and that's just what are we cutting? So we got to pick what we're cutting here. And when I first started, I spent all kinds of time trying to pick all these lines. So I'd pick that, and then I'd hold my shift button down and cut that. And it shows you which way the cut's going. So you can do it that way. It gets very frustrating. I just don't recommend it. So let's exit that out. I'm going to show you a much easier way to do it. All you got to do when we're trying to pick this out is go over here to models. All right, click down until you get where this is our sketch and click on that. Notice it sets them all for you. This is particularly helpful if you got something with 200 different lines on it. You're not sitting there for 2 hours trying to pick each line individually. That can get really, really frustrating. So I will go back to one thing, and this does come in helpful occasionally. So let's go back where we picked each line. So we picked that one, and notice it's got the arrow going that way. All right? So I can actually, if I play with this enough, make it cut the other way. That's the only benefit I can see, is if I need my cut to go opposite of the way the factory sets it, and that does come in handy. And all I'm doing is clicking on the arrow itself, and it shows me which way it's going to cut. So sometimes that does come in handy. All right, let's cancel that out. We're going to go back to the way we normally do it, where we just pick the sketch. All right, so all lines are going to be cut. All right. You move over to heights, that doesn't matter to us. I've got torch height control, so every bit of that is handled by the post processor. I don't need to worry about that. Passes, once again, I've played with these numbers. This tolerance number, we're gonna play with that in one of the next drawings, just to see if that makes any difference. We got sideways compensation. If you hold this, this just tells you, determines how to offset the cut from the selected edge. So examples of left, right, center cutting offsets. Left, compensate left of the selected edge. Right, compensate right of the selected edge, puts the cutting head directly on the selected edge, okay, on center. And that's where I want it, is where it's dead on the center, okay. We'll try it in another, we're going to do several different posts on this. So first one, we're going to leave it center, right? And that's our tolerance, 0.004. It's very minimal. I do like this finishing overlap. So it actually goes, and you know that 0.125 is roughly, what, 1/8 of an inch. So when you get to the end of the cut, sometimes it doesn't cut all the way through, and with that little 1/8 inch extra that it goes on past and cuts it again, helps the part just drop out. In some of your drawings that might be a little much, so maybe we want to change this to a 0.0625, or roughly a 1/16 of an inch, but you can change that. So I'll tell you what, we're going to leave this on the 0.125 for this first cut, and then we'll get into playing with some of these variables, okay? We're not going to worry about smoothing, because this is not a complicated cut. Smoothing is if I had a bunch of circles and lines, and it's just too much to calculate, okay? And I found that the feed optimization button really doesn't make any difference whatsoever either. So I leave that off. So these are the things I'm going to leave to begin with here on the passes. Then our last tab up here is our linking. You don't have to worry about keep nozzle down, because we've got the torch height control. Lead in entry, lead in radius, I've got set at 0. All right, and if you look at the picture on that, that's just telling you, specifies which way the lead in comes. Ours does not have 4 axes, and most of your machines do not, so I've found that 0 on the lead-in radius is fine. We may alter that just to see what it does. All right, lead-in sweep angle, just coming in straight at 90 degrees, and lead-in distance 0. All right, piercing clearance. All right, we've got that set up at 0. This is a distance away from the part edge to start the cut, okay? So we really don't want to leave that there, but we can change that in the post process, and I think it gets changed automatically in the post process. So for this first cut, we're just going to leave that on 0. And then you can also pick if you got a certain place you want it to start cutting. So we're going to leave that up to the machine to pick. If I chose that, I could say, okay, I want it to start cutting here or there or wherever, and it will begin the cut there. So we're going to just leave that, let the machine pick that. All right, we're going to click OK. And if you'll watch over here, we got a check mark saying that the tool path is valid and we're good to go. So we're going to go ahead. We've finish these two tabs. The last thing is to create our numeric control program, which is basically the actual cutting software. So we're going to click on that, and we're going to name this A Test 1. Okay, and notice I've got post properties up here that we can change. We're going to change some of the other settings before we begin changing any of the post properties, so we're going to leave this where it is for right now. If you had a cut chart, it would tell you based on the thickness what your pierce delay should be, what your pierce height should be. The retract height, you really don't have to worry. That's how far it pulls back. 1 inch is plenty there. The cut height will also be listed in the cut chart for whatever machine you happen to be using. So in this particular one, we're a 1/16 off the metal. Our pierce delay is a 1/2 second. And all that is how long, once it gets set in place, how long will that burn before it goes through. So if you got thicker metal, that pierce delay is going to be longer before it actually starts moving the head. So, and then pierce height, that's when it starts the pierce. So that's roughly a little over 1 inch, or 1/8 of an inch, that it will start trying to pierce that metal. It will take a 1/2 second before it pierces, and then at that point the head will start moving and following the program. So we're going to leave all those the way they are for this particular one. We're going to hit post. And you can see we've got all of our G code here that's going to tell the machine what to do. All right, so we're going to pause that. Now we're going to create another one. So we're going to go back to our cutting, and we're going to change. We're going to create, and notice that we've got one NC program, one setup. So we're going to go back and we're going to change this time. So I'm not going to fool with changing cut rates, because we can do that on the Crossfire control. You'll see that later. Notice our machine, all that's already done. I'm not going to change any of this, so we're going to go ahead and choose our sketch again. Where we're going to start making changes is right here. So let's try this one. Instead of sideways compensation center, let's go sideways compensation left. All right. And we're going to leave that there. We're going to leave the outer corner mode. Pretty much leave all these other variables alone. All right. Because we only want to change one variable every time. I don't want to change anything else. So we're going to go left for our sideways compensation on this one. We're going to click OK. And once again, we're going to create an NC program for this one. And we're going to put A Test 2 sideways compensation left. So we know exactly what we did with that one. And let's post it. Once again, we're changing one variable at a time. All right, let's go back and do it again. So let's go to cutting. We're going to leave all this the same. Pick our geometry once again as the sketch. Let's come back here. Let's go right this time on the sideways compensation and leave all things else the same. Let's click OK, and we're going to post that. So this will be A Test 3 sideways right. Post that. All right, let's add some different variables this time. So we'll come back to our cutting. Once again, we're not going to change any of this up. Let's go ahead and choose our sketch is what we're cutting out. And let's go leave all this alone this time. We've already changed all of those up. And let's start making some changes here. So let's change our lead-in radius this time to, I'm going to make it something ridiculous so we can see what that does. So we're going to change that to a 1/4 inch on the lead-in radius and see what happens there. Okay. And I think we're going to do nothing else there but change the lead-in radius to 0.25. And notice we get an error. So that one apparently is not going to work. So let's go back up and let's edit that. So 0.25 on the lead-in radius. Let's see what, let's reset the system default. Okay, so 0 is the system default. So let's leave that alone. All right, lead-in sweep. Let's just see what the system default is there. 60 degrees, okay. So we'll change that and see if it makes any difference. And let's set this one to the, okay, so that we got a lead-in distance. Let's make this a little more pronounced. So right now, well, let's leave it. That's almost a 1/4 inch, so that's pretty pronounced. So we're going to change this to the system defaults and see how this does. So we're going to put on this one, lead-ins are system default when we save this. So let's hit OK. We still are getting an error message. And you can see what's going to happen here. This time it's going to come in from this way and cut all this out, but it's not cutting this for some reason. All right, so let's go back and see if we can see why it's doing that. So let's go back, let's edit the tool. And somehow or another it's not, all right, let's see if we have to change it. Maybe we have to manually choose it to get it to do that if we want this to go. And once again, we can't change this. So 60 degrees, 0.19, 265. We might have to change that to 0.05. Let's try that and see what happens. So let's click OK. And we're still getting a system error, and you can see we got dark blue lines here, but it does not want to cut the center out. So let's see what we're doing wrong here to find out how we can fix this. Let's take away this contour selection. Let's just go back to our normal choose the sketch. All right, passes, we left all that alone. I'm just wondering if we have to change these passes to get it to do that. So if we leave our leads here, lead in, lead out, our pierce clearancing, let's try and make it, let's see if we can force it to start right there. Okay, that worked. So we forced it where it's going to come in and cut here, and it's going to come in and cut here. So on the scale of things, I'd say that A is probably going to look a little better as far as the cuts go, but we'll just see. We're going to go ahead and put that I'm going to put this A test 4 factory default lead in. And let's post that one. Okay, so once again, I'm kind of learning with you on how this works. I think we're good to go there. Let's try one more variant. So let's come back to our cutting. All right, I'm going to choose our geometry again, which is this. On the linking, we're going to leave that as we were in the original. And we'll leave all this alone. So this is back pretty much the way I had it set in the very first cut. And we're going to leave everything alone. We're going to hit OK. And this time we're going to play with our post processor. So we're going to leave our cut height at 0.063 because I know that's where it needs to be for 1/8 inch. Our pierce delay at 0.5 and our pierce height at 0.15. let me just show you what happens if we change this up dramatically. So let's say we do our cut height at 0.25. We're more than likely going to get an error because it's not going to give us a good one, but we're going to change this. Let's put A test 5, cut height 0.25, and let's post that. Okay, I'm sure that's not going to be a pretty cut. All right, folks, that's pretty much it for this video. This will be everything that we're dealing with here is going to be out of 1/8 inch stock or 11 gauge. We're going to make these 1, 2, 3, 4, 5 cuts with the machine in our next video where you can see the difference on which one's which. And I hope this helps you out. In one of our next videos, we'll just bump the size metal up to 1/4 inch, then we'll go to 3/8, and then we're going to see if we can actually cut some 1/2 inch. So, hope you enjoyed this video. I hope it's helpful. If you got any questions, just please feel free to message me, and I'll see what I can do to help. But once again, thank you for joining. Have a great day. This is Tim with One Handy Guy.